Okay, so I think my voice is clear, and then you can see my screen. Can you hear me? Is it my voice clear?
Yes.
Okay. Okay, so in the previous session, we started on with the Snowflake, the core purpose of data warehouse, and we have seen introduction to Snowflake. So we went into Snowflake and we created a table and we loaded a data. And then we saw how we can load the data using copy command. That is what we have seen in the previous session. Today we will understand the architecture of Snowflake. Okay, so we'll understand the architecture. Understanding architecture is very important. Okay, so it will give you a lot of ideas about the platform, about the performance, about what is happening internally within the Snowflake. You'll get a good idea. So understanding architecture is very important. So today we are going to understand the architecture, and we are going to look into the core layers, how Snowflake functions. Okay, so we are going to understand the core layer here. Okay, so that's what we're going to do. So we're going to understand Snowflake architecture. So we already created a table. We created a table, we created a stage, and we did a copy command. So we are going to see how the data transferred happen. How did the data movement happen? So we had a multiple cloud account. So how the data flow from one account to other account, we'll discuss about that in detail. Okay, so the previous session we started on Snowflake. So you should already have access to Snowflake. So you should have access to Snowsite. So we have seen how to log into Snowflake, how to access Snowsite. So in the Snowsite, I have admin access. So you can see I'm my account admin. So I have admin access. So I can create database, I can create tables, I can run SQL, I can run Python worksheets, I can do all kind of activity because I have admin privilege now. Okay, so in the Snow site, you can see in the Snow site, as you log in as an admin user, account admin, I can see here, I have all the privilege here. I can see the database. I can explore my database. I can see my users. I can see my roles. You can also explore my warehouse. I can see what are the warehouses are there. I can explore all the options in because we logged in as an account admin role. So we have the super admin privilege. We are able to see advanced options here. Okay, we are going to use Snowsite UI for doing SQL, for doing some lot of operations. Okay, so Snowflake, first let us understand the architecture. Then we will discuss about the capabilities. We'll discuss about the future. Okay, so let us go to Snowflake architecture. So before going to architecture, so as already we discussed about, Snowflake is a fully managed. It runs only on the cloud, and you are going to do SQL. You are going to do SQL everything. If I'm going to create a table, I can do it SQL. If I'm going to create a function, I can create it as SQL. So it works with the SQL. So we can create everything using SQL here. It supports ACID transaction. Okay, so it supports ACID transaction. So it has full consistency. Okay, and everything is SQL driven. Configuration, optimization, data management, everything is SQL driven. Okay, so we'll come to this part later. We'll get into the architecture first. In Snowflake, we have three layers. Okay, so the architecture, you have three layers: storage, compute, and cloud services layer. Okay, so traditional data warehouse architecture. So if you see traditional data warehouse architecture can be like shared disk architecture or shared nothing architecture. Okay, these are the traditional data warehouse architecture. So in shared disk architecture, they have disk is shared between CPU and they have RAM. They share the disk. So this is the old way of doing. So the scalability is a problem. In a shared disk architecture, scalability is a problem. If you want to scale it up, the you are as you are using the disk is shared, scaling up becomes difficult here. So scalability is the biggest problem in the shared disk architecture. Shared nothing architecture, so where they use they use multiple machines, and the data is not shared. The data is splitted here and processed it parallel. So shared nothing architecture, they don't share the data, but the data is splitted into multiple parts. So in a shared nothing architecture, they have their own memory, they have their own CPU. Data is splitted into multiple parts and parallelly processed. So again, this here, so your data warehouse systems Redshift is under shared nothing architecture. So where there you do data partitioning. So you do data partitioning here. So you have to do manually auto tuning here. You have to do performance tuning. You have to do lot of tuning here in the shared nothing architecture. Whereas your data warehouse, like your Snowflake, is a hybrid architecture. It's a combination of both this architecture. Let me try to close this one. So your in a traditional system, it can be shared disk architecture, it can be shared nothing architecture, but Snowflake is a combination of both. Here, your cloud storage is a shared disk architecture. Your cloud storage is a shared disk architecture, and your compute is shared nothing architecture. Okay, so they have hybrid approach here where they have three layers here. They have storage, they have compute, and they have services layer. Okay, so what is this? Let us see this in detail. Okay, so if you see here, so when I log in, so when I log into Snowflake, so I'm logging into Snowflake as an admin user, as a super admin. So I can log into Snowflake, I can create users, I can create database. So whatever I'm doing it on the console, on the Snow site, I am working on the services layer. Okay, so you are working on the service layer. So once you log in, the service layer is responsible for access control, security management, authentication, authorization, transaction management, infrastructure, metadata management. Your service layer is responsible. So from whatever I do it from UI, I am operating on the service layer. Okay, so in the architecture, you are doing it from UI. So here I'm creating users, I'm creating database, I'm creating tables. Okay, so whatever I'm doing it on UI, I'm working on the service layer. So your Snow site is part of service layer. Your Snow site is part of service layer. So you have three layers here. So you have the data is permanently stored in the storage layer. The data is permanently stored in storage layer. So what is the storage? So your Snowflake is built on top of cloud. Snowflake is built up of cloud. So they use cloud data lake for storing the data permanently. Okay, so when I create a table, and load the data into the table. So here I'm creating a table. Okay, and then loading data into table where the data is stored permanently. Data is stored permanently in your data lake. Your Snowflake is creating the table and storing the data permanently in the data lake. Okay, so the storage layer is where permanent data is stored. Then query processing layer is compute. Your query, whatever SQL you do, whatever analytical queries you do, it is ran on your warehouse layer. Okay, here you have a caching mechanism. So here you can cache the data. So if I run queries multiple times, so if I run the same query multiple times, so if I run the same SQL multiple times, it will be cached here. Okay, so we have multiple layers. So each layer is responsible for different things here. So each layer is responsible for different things. So we have to understand what is happening in each layer. So your storage layer is responsible for storing the data permanently. Okay, so the data is stored here permanently. Here the data is stored permanently. So it is highly scalable because they are using data lake. It's highly scalable and I can store petabytes of data and I can, it is very cheaper. So it's cheaper. Okay, so that is why your cloud-based data warehouse systems are popular because it's using cloud and it's storing the data permanently in the data lake. And then the storage is cheaper here and it is highly scalable. Okay, and the compute, it's a virtual machine. So you are using a virtual machine. Okay, this machine can be small machine. This can be large machine, can be extra large. So you can choose a different type of machines. So it's nothing but a virtual machines. So this virtual machine this is a query processing layer which is responsible for compute, So whatever the transformation I do, whatever the SQL I do, it runs on the compute layer. And data is permanently stored here. And you have a caching layer. And this is the service layer is the interface here, which is the interface which helps you to work on the Snowflake system. Okay. So your architecture has three layers. So we have service layer, compute layer, and storage. Now let us go to the scenario. In the previous session, we used a cloud account. So I have my cloud account. I have my AWS cloud account. Okay, so this is my AWS cloud account. I have data here in S3. Okay, I have data in S3. So I have data here. I have the sales data here. So let me do one thing. Okay. So far I have two AWS account. I have two AWS account. So AWS account 2, AWS account 1. Okay. So AWS account 1. My Snowflake is here. My Snowflake is here. And my Snowflake has three layers: service layer, compute layer, and storage layer. Okay. So my Snowflake has three layers. So this AWS account, I don't have control over this. Okay, so I cannot access it because I have subscribed to Snowflake. So I have subscribed to Snowflake and they have provided me this account. So if you go and see this account, I can see the account details here, your account details. I can see the account identifier. I can copy this account identifier. So this is the account ID. This is the account name. So this is my account name. So this is my account 1 where I have Snowflake and it has service layer. It has compute warehouse layer and it has storage. Okay, storage is in this AWS account, they have S3. They have S3, which is used as a storage. So can I go and access this S3 bucket directly? I cannot access it because I don't have access to this. So this account is managed by AWS. It's a proprietary solution. The Snowflake is a proprietary solution. If you want to store the data here, only by creating table, I can store the data here. Okay, so I cannot access there directly S3, but this S3 account, this account is my another account. I have S3 here and I have a bucket here. So this account, we had a CSV file we have a CSV file, sales CSV. So this is what in the previous session we loaded into Snowflake. So what we did, so we created a table. So we created a table and we created a stage. So we went and created a stage. So stage is nothing but you are creating a link. You are creating a link. Okay, you created a link and then we used copy command. Okay, we created a stage using AWS credentials. So we used AWS CLI credentials. So AWS credentials to create the stage, and we did the copy command. So this is how we brought the CSV data into the table. Okay, so we brought the table. So we created a table and we loaded the data. So when we loaded the data, when we did a copy command, the data was moved here into the storage. Data was permanently stored here. So data is permanently stored here. Okay, and if I run a SQL, my SQL ran on the warehouse and I created all the table, I created database, everything using service layer. Okay, I operated on a service layer. I used Snowsite. So I used Snowsite. I created table, I created database, and I worked on the service layer. We access the service layer and then we created tables. So this is how we worked in the previous session. Okay, so previous session, we created a table, we created a stage, we loaded this account to data into Snowflake, and the data was permanently stored here. So let me do it again. Let us do this step again. I'll go to Snowflake. I'll go to catalog. I can see the database. So I don't see demo database. So this is my fresh shade Snowflake account. This is my fresh Snowflake account. I have not done anything. So this is a different account from the previous session. So it has only one user. If I go and see here, I have only one user. So I have one user and there is no database here. So learning database is there. It's a sample database. I have not created any database. So I can go here, create a workspace. I can create a workspace. Create a new workspace and create my database, create my table. Okay, I can create everything step by step. Okay, so you can see here, I will copy the commands here. So this is the thing we did. So we first used account admin here. We used account admin, super admin role. So I used account admin because I'm going to create database. So I need admin privilege. So I'm using account admin and I'm creating database. I'm creating schema. So everything I'm doing as a SQL. Okay, I'm doing as a SQL. So I can save this one. Demo 3. I'm saving this note. I'm saving this SQL worksheet. So it's saved here. So next time, if I access it, I can access the SQL here. Okay, so I can save this notebook. So I can run this command. I can select all this thing. I can run this command. I can select one by one. I can select one by one and run the command, or I can select everything and run the command here. So let us see what we are doing here. Creating database. So you can see the comments here. I have given the comments. Creating database and schema. I am creating stage. I am creating stage. Okay, so I'm using AWS credentials. I'm using AWS credentials. I'm creating a stage. I'm creating file format. Here is the actual one. I'm creating table. Okay, I'm creating table and then I'm loading the data, the CSV file. I have a CSV file here. I'm loading the CSV file. So this is my account to. Okay, I'm loading the account to data. I'm using copy command, loading into Snowflake. Okay, loading into Snowflake. So here, so the account to, we have the bucket. We have the bucket. So in enterprise, let me go to this diagram. So we may have multiple AWS, we may have multiple AWS account. So this can be AWS, this can be Azure account also. So in multiple cloud accounts, you can have. So I have AWS account, I have Azure account. Okay, I have data in multiple places. I have multiple accounts. I can create a stage. I can create a table, load the data. So this Snowflake is a centralized warehouse where I can bring the data from multiple accounts. So this account is used by, let us say this is by sales team. Okay, sales team is using this account and they have this data. So this data is coming in from multiple sources. Okay, so here the data is coming from SAP or the data is coming from Oracle. So from the other sources, from other source system, the data is loaded here. The data is loaded to S3. So I am taking this S3 data and copying into Snowflake. Okay, so I have account 2, I have marketing team. So marketing team, which is using AWS account 3. I have Azure, different like operations team. I have operation team who is using Azure account. Okay, who is using Azure account? I can create a stage for AWS. I can create a stage for AWS. I can create a stage for Azure also. I can create a stage for Azure. Even though I'm using Snowflake on AWS, but I can create a stage for any other cloud account. Okay, so I can create a stage for Azure account also. So I can create a stage for Azure. Okay, and then I can access the data what is stored here. I can access this data stored here. I can access the data what is stored here. I can load this data into Snowflake. So why we are doing repetitive work? So why we want to do repetitive work? So the data is already here. So why we want to bring it to a centralized place and then why we want to organize in a nice way? Because I'm working for an enterprise where they have multiple teams, where the data is coming from multiple systems. So I want to organize it nicely and I want to consolidate. I want to collect the data from all the sources, then allow my consumers to use it. I have multiple consumers. So here I have multiple consumers. So the consumers can be a different type of consumers. So I have like a marketing team. So who is going to consume? I have BA teams. I have BA teams. I have multiple consumers. I have ML team. I have multiple consumers. So I am going to allow consumers. So consumer 1, consumer 2. So I have multiple consumers. So why they are accessing the account 1? Why they can access directly the account 3? So we have account 1, which is bringing the data from account 2, account 3, account like here, like let us say Azure account 1. We'll say Azure account 1. Okay,
Sir,
so I have, yeah.
I have a doubt. So why that AWS account one there? Because that is a Snowflake environment, right? That level.
Yeah.
So why it is you are mentioning AWS account one?
So Snowflake is a cloud-based data warehouse system. It runs on the cloud. Okay, it is using a cloud account and it is operating on a cloud account. Okay,
Is
so
this a separate account? Is this
yeah,
a
it's a
separate
separate
account?
account. It's a separate AWS account.
Okay, fine, fine. Hmm.
So here the account 2 is only working as a source, right?
Yeah, we are using account too. I will add account, Azure account also. So we will use
I mean,
multiple accounts.
these accounts are working as a source, or
So all
does
these
it have
accounts are
other
source.
purposes?
Yeah, all
Okay.
these accounts are source.
You mean that AWS account one is a data center, right? AWS is a data center we are using.
Yeah, it's a AWS account. It's a data center. It's like another AWS account where Snowflake is installed and Snowflake is managed by. So we don't do installation here. It's managed by Snowflake team. So we just have AWS account and we have installed Snowflake there, and it is managed by Snowflake team. So we don't know what is there, how they are doing it, all this thing. We are not managing it. We are using as a service here. We are using software as a service. Okay, we have
Okay,
subscribed to
while
Snowflake. We got
creating a
license. Yeah.
yeah, while creating a trial version of Snowflake, so
Yeah.
initially it will ask AWS as your GCP. So we
Correct.
opted AWS.
Yeah, correct. So when you opted that, so it's creating AWS account.
Fine. Okay.
Okay. So we have one centralized AWS account, and I have multiple sources here. I have multiple sources. So these are the source where you are bringing data. So here I can bring data from multiple systems. So I am bringing data from multiple system. I'm going to bring the data into marketing team or operations data. So the data is going to flow from multiple accounts. The data is going to come into the centralized data warehouse system. So why we are doing this? Because we want to collect the data, and this data are in raw form. The data is in raw form. So the data has low quality. That is the main thing here. This data, if consumers use it straight away, they are not going to have much impact because this data is in raw form. The quality of data is poor. So this data has to be cleaned. This data has to be transformed. This data has to be cleansed. So you have to transform this data. You have to validate this data. So the data is coming directly from source are very in raw form. So you are having a CSV data or JSON data, which is a raw form of data. Okay, so that is why we are having it in data lake. Then we are moving into data warehouse. So data warehouse, here we have organized data. So in the data warehouse system, we are going to have multiple layers. So here we may create raw data, processed data, aggregated data, or we are going to create data models about our consumers, different type of business tables. We may create business tables here. So here we are going to create different, we are going to do data modeling, and we are going to create different type of data. We are going to create different type of tables, and we are going to transform this data and load it here. Let me quickly. So bring this one here. So if you see here, in this layer, we are going to have raw data. We are going to do cleaning, data validation, standardization. We are going to do aggregations. We are going to enrich the data. We are going to do business specific scenarios. So here we do transformations. We transform the data and we convert the raw data into different forms. So this data becomes cleaned, standardized, and this data can be used for consumers. Okay, so now consumers can access the data. So if they want the raw data, they can take the raw data. So for example, here I have different type of users, different type of consumers. So I have ML, AI teams. Okay, I have different type of consumers. So I have BA, business intelligence team. So they need business specific aggregated reports. They want only aggregated data, gold data. They are going to access only gold data. So they can access it from gold layer here. And I have marketing team. They have web applications. They have some devices. So they want aggregated data. They want cleaned data. Okay, so they have their own dashboard. They have their own dashboard using JavaScript applications. Okay, so they are going to access silver data, or they are going to access silver layer and gold layer. Okay, so they are going to access silver layer and gold layer. And I have machine learning team, AI team. They want raw data. They want cleaned data, silver layer. They are going to access bronze, silver, both. Okay, so my consumers. So here, my consumers don't have to go into each of the system. Okay, they don't have to go into the other business unit data, this business unit specific data. So this they don't have to get into account 2, account 3 data, account specific data. You have organization data here. You have raw data, cleansed data, aggregated data. So the consumers can use it straight away. So this is how in data platform, Snowflake helps us to create staging environment, create different type of data models, and helps us consumers to access your data. Okay, so Snowflake provides you easier options to create these tables, load this data, okay, create stage environments, and load it into your Snowflake environment and allow consumer to use it. Okay, this is how real world your Snowflake is used. Okay, so now we'll go back to the architecture here. So we'll go back to the architecture. We will now let us understand. So in the architecture, okay, so when we created, I'll bring the architecture here. So it's easier to discuss. I'll bring the architecture here. So we have layer. So we have different layers. So when I created table, so when I created a table, I created a table and I loaded data. I used copy command and I loaded data. So let us go to the SQL. So you can see the copy command here. So I have a table. I created this table, sales record, and I loaded this data. So let me do it quickly. I'll create all this thing. So I'll first create database, schema. I'm creating first two database and schema. Then I'm going to create stage. Okay, here I need credentials. I need AWS credentials. So I have a AWS. So I'm using this bucket. So this is my AWS account. In AWS, I'll go to IAM. In IAM, I have users. So I can create a new user.
We realized we need a bigger format to and capture their microbusiness. So then we thought of how can we do that? How can we go about it? And obviously, IMAX is the first thing that came to our mind. And when I first revealed the glimpse, the audience should see it in the big screen. And unfortunately, we don't have much of big screens here in India. And we had this audacious thought that if we don't have, let's build one. And we literally built that 100-foot by 130-foot.
So I think somebody has unmuted.
Once we
So
start
can you please unmute
Yeah,
Varanasi.
I think I can see Venkateshwar Reddy.
yeah. Can you go on mute? I'm getting a lot of disturbance from background. I thought it is a question. Okay, so what I'm trying to do is I have account 2. So in the account 2, I need to create a stage. I'm going to create a stage. So I need to create a user. So let us go to account 2. So in the account 2, this AWS account, I'm going into IAM. IAM is a service. So in AWS, you have identity and access management. So where you can create users. Okay, you can create users here and you can give permission for the users. So in the account 2, I'm creating a new user. I'll go to AWS IAM. I'm going to create a new user. I'll say Snowflake dev user. I'm creating a new user. I'll say January 2026 or let me say February 2026. So I'm creating a new user here in AWS IAM and I'm not giving any permission. I can attach policy. I can attach permissions here. Okay, I can give permission now or I can give permission later. So for now, I'm not giving any permission. I'll just go and create a user. So I created a user. I can see that user here, Snowflake. So this is the user. So I created a new user in the account 2. And then that user, I'm giving a permission. add permission, attach policies directly. I can give S3 full access, or I can give access to specific bucket. Okay, so in this scenario, I need access to only this bucket, but I'm giving S3 full access. So for that user, I'm giving full access. Okay, I gave full access, and I can go to secret credentials, and here I can create access keys. You can see here. So this is the access key which we are using it here. So this access key, we are creating it here. You can see application running outside of AWS. So you can click on this and create the access key. So this is how we create the access key. I can copy the access keys. I can paste the access keys here. So this is how I created a user and I gave access to the S3 bucket. Okay, that user has permission to that bucket. Okay, I created a user. Now, if I run this command, I can create a stage. I can create a stage and I can list the stage. I can see the files. Okay, I can see the files. Now, I'll create a file format because I'm going to use CSV file format. I am creating a CSV file format and I'll create the table here. I'm creating a table. So you can see the syntax here, create table, a normal syntax. We are defining column names, data type. So I'll explain about data type later we will see detailedly. So what are the Snowflake data type, how it is supported, we will see that later. For now, I'm creating a table and loading the data. So this we did in the previous session, same thing I'm doing it. I'm running copy command. So I'm taking 5 million data from the data lake and I loaded into Snowflake. So when I run this command, what happened begin? Okay, so when I run this copy command, what happened in begin? So let us discuss now about that. So I'll go to architecture. So what I did here, we created a stage. I'll delete few of this thing. Okay, so we created a stage. We use CLI credentials. We created a stage and we ran the copy command. When I ran the copy command, the CSV file data was loaded into the storage area. Okay, so it's loaded into storage. The data is permanently stored here. Okay, data is permanently stored here. You can see now the data is moved from the account 2 and it is brought into account 1. The data is permanently stored in. So now we have created a table. This table is an internal table. This is the internal table. So internal table. So the table is the internal table and the data we loaded into the table, the data resides within the Snowflake. So the data is sitting here and the data is stored in a micro partition. Okay, so in Snowflake, by default, they have a concept called micro partitioning. What they do, they take the data, split it into multiple chunks and store the data in micro partition. So because they are storing in the storage permanently, they are not storing as a one file. They are converting into small packets. They are storing as a micro partition here. They are storing as a small packets. This we call it as micro partitioning. Okay, so it is called micro partitioning. So they also take column statistics. They have the column statistics here. So they have the column statistics. So min and max value, they have it here. Column statistics. So they have the service layer, they have the column statistics, and micro partitioning is there in the storage layer. So when the data is loaded into Snowflake, they convert this data into micro partitioning, and then the data is loaded into Snowflake permanently. Okay, so here, let me go into.
Is there any size attached to these partitions?
Yeah, there is a size. Like default, it's like 50 MB to it's 500 MB of compressed data. It can be within 50 MB to 500 MB. So they have their own mechanism for creating micro partitioning. We will not know how they are doing it. The technique and then everything is hidden from us. So they are doing the micro partitioning internally. Okay, why they are doing micro partitioning here? Why they are doing micro partitioning? So you can see here. So this is how the data is stored. So the data, so whatever the data, the CSV data we stored is split into micro partition and stored in the storage area, stored in storage areas, multiple micro partition. And in the cloud services layer, they have metadata. In the metadata layer, you have min max value. You have the minimum and maximum. So why they do this? So what is the purpose of doing this? So this helps Snowflake to do faster performance, faster SQL. Okay, so the micro partitioning, the metadata management helps Snowflake to do faster SQL performance. So we'll discuss that. So far we have seen in Snowflake, when they store the data permanently, they store it as a micro partitioning. So they create micro partitions and store the data permanently. And that micro partition size can be within 50 MB to 500 MB, average of 50 MB to 500 MB. So here they don't store it as a one chunk. They split it into multiple chunks and they have column statistics separately in the service layer. So what is the mechanism behind why they are doing it such a way? So in big data systems, when you are working on large data systems, so partitioning, okay, let me clear this one. Full scan is a costliest operation. Full scan is a costlier operation. So let us say I have 100 million or 1000 million of data. Okay, I have 1000 million of data. So if I store this as a single file, or I split it into 100 parts, I split it into 100 parts, or I split it into 1000 parts. Okay, I can store this as a one file. I can split it into 1000 parts. Okay, I can split this into 1000 parts. I can store this 1000 million in small parts here. If I can avoid reading all this partition and scan only few partition, if I scan only few partition and avoid all the partitions, this will help me to improve the performance. So in big data systems, you always create partitions. You create partitions, and by doing partitioning, you scan only few partition, ignore the other partitions. So that is what by default Snowflake is trying to do. So by doing micro partitioning, so it's happening default. We don't do it. They calculate the size 50 MB or 500 MB. They split your data into multiple micro partitioning. So they create the micro partitions here. So
So,
they create the micro partition.
so how it is decided, like which partition to scan and which one not?
So they have done an algorithm. So they are maintaining the column statistics. Okay, they are taking the column statistics. You can see here. So they have the metadata. They have min and max value. They have the min and max value. So they try to. So for example, let us take a date value. So date, you are starting from January 1st. You are ending with December 31st. So they take January 1st will be there in micro partitioning one. They know this, and like you have MP 100, December 31st is there in this partition. So they are maintaining column statistics. So they are maintaining the metadata. So they have the metadata systems maintained separately. Okay, so we cannot access the metadata tables, but they are maintaining the column statistics. So based on this, they know that the filter condition. So if we apply a filter, so if I use a date column when I'm writing a query, when I apply a filter based on the date, so if I apply a filter on January 1st, it's going to micro partitioning one. It's going to scan only micro partition one. It will ignore other partitions. So that is how by doing a micro partitioning, you are going to have faster SQL. You are not going to do full scan. You are going to scan only few partition. So this will help the performance of the system. It will help the performance of SQL. You will have a faster performance here. Okay, so let me show you. For an example. Let us create a table. I'll create a new table. I will load the data into the table and we will see this how micro partitioning works. We will see this now. Okay, I'll create a new simple table. I'm creating a simple sales table. I'll use demo database, demo schema. I'm creating a new table.
So in the system, the partitioning is done automatically, and here our part is only to apply the filters in the SQL,
Correct,
right?
correct. Yeah.
Okay.
The partition is done automatically. We don't create micro partition. It is done automatically. Only when the data is about terabytes, then we create clustering keys. Okay, so about 1 terabyte, below 1 terabyte, it is taken care by the Snowflake itself. We don't create micro partition. Snowflake internally does that.
Okay.
Okay, you can see here micro partitioning. Snowflake automatically partition data into small, optimize micro partition for faster retrieval. Okay, you can see the futures in the storage layer. When Snowflake stores the data, they store the format in compressed form. So they store it in compressed form and they create micro partitioning automatically. We cannot see the data, how they are doing it and what basis they are using it. We cannot see it, but internally everything happens. Okay, so let me create a table. I have created a table called sales MP demo and then
Well, so for a specific use case, if I want to avoid partitioning of Snowflake, how do I do that?
you want to avoid micro partitioning.
Yeah, for it,
You
there is
cannot
a
do it.
specific use case. I completely
You
want
cannot
to
do it.
avoid or bypass micro partitioning.
You have to
How do I
create an
get to it?
external table. If you create an external table, there will be no micro partition.
Okay. Mm-hmm.
Okay, if you created an external table, then there will be no micro partitioning created. You are just going to use the table. So micro partitioning helps you to improve the performance. It is a so it is going to store your data and then it's going to take your column statistics, maintain the column statistics. So when I do queries, my queries will be faster because of that. Okay, so they internally they understand your column statistics. They create the column statistics metadata tables for you, and they maintain it metadata tables separately. So that is how they are doing the auto tuning of functionality by default for all the tables. It's a default behavior of Snowflake. It's there in the internally within the Snowflake.
Sure.
Okay. So far I created a table. I'm going to load a data here. So I'm going to load some first 500,000 record into this table. Okay, I'm going to load some 500,000 records. Now let us check how many partition the data is there. So let us check now. So I'm using select star from table and I'm using a filter. If I run this query, it will show me, I'm saying, I explain. It shows me what what is the internal operation. You can see here partition total, partition assign one. So far for this 500,000 record, it used only one partition. It used created one partition. So if I run this query, okay, you can see this query output here. I can also go to query history. I can go to the Snowflake query profile. I can see it here. So partition scan, total partition one. So my data size was less. So it created only one partition. So let me increase my data. I'm going to load some I'm going to load like 50, 150, 15 million. I'm going to load 15 million. Let us see now. So I did not create any partition here. I just created a table. Now, if I go and see, I'll run the explain. You can see partition total 9, partition assigned 1. Okay, so as I applied a filter, it assigned only one partition. Okay, so I can run this query and then see the query profile. So I ran a query. I can go to query profile. I can verify it, how many partition, whether it did full scan or it did a partial scan. Like, let me check it again. I'll change the date here. You can see here, partition total is 9, but it scanned only one partition. So by default, 9 partition got created and it's scanning only one partition. You are not doing full scan here. As I use the filter condition, it is scanning only one partition. Whereas, let me do one thing. I'll go for weak filter here. I'll go for a weak pruning here. I'll randomly, I'm going to take amount and I'm going to do this operations. So when I use this query, I'm running this query. Let us see how many partition is going to scan. So I'm using a weak pruning here. So this is I'm using amount greater than 10. Okay, so what Snowflake does, let us see how intelligently Snowflake does. It's going to scan all the partition because you can see now partition scan 9, partition scan. So here I applied a filter, a date column. So it went into my column statistics, identify the min value, max value, and scanned only one partition. So it scanned only one partition, avoided the 8 partitions. Here it did not find column statistics. Okay, so it did not find column statistics. So it did a full scan. It ran again all the partition. So this is how internally, because of micro partitioning, you are going to avoid, you are going to do it. So you can see most expensive operation, you are doing expensive operation here. So this query is expensive query. This is a optimal query. We are running an optimal query. Because here we are using a filter condition and that data we are applying on the subset here, subset of data. So it's not doing full scan, it's doing a partial scan. So you'll get a better performance. So you can see now, so how Snowflake efficiently is able to do micro partitioning by default. So I created a table. I did not define any partition column. I just loaded the data. Snowflake created the partition internally. Okay. So this is how internally Snowflake does. So in the Snowflake, when you create data, when you load the data, micro partitioning happens automatically in the Snowflake.
The micro partitioning is happening on based on which column, how we can know that normally.
It takes all the column and it maintains the statistics of all the min and max value. So you need to know. So when you are choosing the filter condition, you should not choose a unique values. If you choose a unique value, it will do full scan. So here I used amount. When I used amount, it did a full scan. But when I used order, so here the order has only, it's a low cardinality column. The order is a low cardinality and this is a high cardinality column. That means when you choose the columns, your Snowflake is going to understand what is the uniqueness of the columns here and which has unique values that it is not going to maintain, where it can have distinct values. So here if I will identify what are the distinct values, so it will run a query.
Okay, yeah.
So it can take your min and max value and count are there. For the date, you have only 2000 count here. Okay, so it can split your data into 2000 parts here. Okay, so the date value, we have 2000 parts. So like that, Snowflake internally, for each of the column, they identify the column statistics. So they maintain the column informations, the column statistics information internally. We cannot access it, we cannot see it. They maintain it internally. They are not going to maintain for all the columns. So for the
And
low
even we cannot
cardinality
access
columns,
in sense as a developer we don't do, or admin they will be taking care.
yeah, even admin cannot see the micro partitioning, all the metadata columns, they cannot see it.
Okay.
Okay, so it is a default behavior. It's a micro partitioning is a default behavior, and they identify. So, but when we are designing the tables, we should know what column we are going to use it for filter conditions. So, I should use a column which has low cardinality. So then what will happen? So your Snowflake will use the column statistics and it will create micro partitioning in a better way. So it's going to choose it. So when we have clustering keys, which we'll see it later. So that is an advanced concept. If you have 1 TB of data, then we can define the clustering keys. We can cluster the data. So that we will see it later. So for now, we are using micro partitioning. We are not defining any partition. We are leaving to Snowflake, and Snowflake is taking care of creating the partitions, micro partitioning. We are just loading the data into Snowflake, and we are choosing the right filter columns here so that it can do full scan, or it can do partial scan. So if I don't use the correct filter condition, it will do full scan. It will scan all my data and get me the result. If I use the correct filter condition, it will scan only few partitions and it will give me the. That is how my queries can be faster in performance. Okay, so far, yeah, go ahead.
But while
Yeah,
designing, we need to understand how the low cardinality, all that.
Yeah, I'll explain it. We will see that later. I'll tell you how it is done, how the selection of column is done, how we decide the cardinality column, how do we design the filter condition, everything we'll discuss later.
Okay.
Okay, when we are working on the project, I'll tell you how the cardinality column is chosen, how the filter condition is chosen. I'll tell you that.
one more thing. So to practice all these things, we have to create the user in AWS, right? And
Yeah,
how
you
do we
have to
get the
create.
data?
Yeah, so there are multiple ways, right? So you can create a stage. You can create a stage, internal stage also. You can create internal stage and load data, or you can create a AWS account and you have to create a user in AWS and then you use the account from AWS. That is a better one. Then you will get a good understanding about data lake, creating users in Snowflake, and then working with AWS integration, you get a good understanding.
And how
So
do
if
we
you are,
get this data, the one which you are using?
I'll be sending the data files. Everything will be
Okay.
attached to the course content. In the weekend, you will get access to the learning portal. In the learning portal, you will see all the files will be uploaded.
Okay.
Okay. So if you see the previous batches, right, you can see the zip file. You can see the zip file, day 2 zip file, day 3 zip file. We will have the SQL and the data files will be uploaded in the learning portals. Okay. So far we discussed about the architecture of Snowflake. We discussed about how the storage mechanism happens, how the storage, like how micro partitioning is implemented, how Snowflake does the storage. So let us see that the architecture layers. Let me get into the. Okay, so you can see the architecture here. So we can see the shared disk architecture, shared networking architecture. Then you can come to the Snowflake architecture. So in the Snowflake architecture, in the storage layer, so here we have the centralized permanent data is getting stored. It's stored in the object storage. It's stored in S3 or blob storage. and they are doing automatic compression of data. They are doing automatic compression, and they are using micro partitioning. Data is divided into data is divided into 16 MB micro partitioning. Okay, so it's 50 to 500 MB raw data. Compressed data is 16 MB. So this is a compressed data, size of compressed data. But the actual data size can be between 50 MB, 50 to 500 MB of data. Okay, that is compressed to 60 MB of micro partitioning. Okay, so your storage layer, which is responsible for micro partitioning, time travel mechanism, fail safe, data sharing future. So your storage layer is responsible for all these features. Okay, and your compute layer is responsible for caching mechanism, concurrent scaling, okay, resource management, auto resume, auto suspend. Okay, so your compute layer has all the scalability features. So I can improve the performance of my SQL. I can improve the performance of my running queries. I can choose a bigger warehouse. I can improve performance. I can do auto suspend, auto resume. I can do concurrent running of things. And your service layer, you are responsible for authentication, authorization, metadata management, governance. Okay, so it's responsible for all the interfaces. So it's the brain of the system, which is doing the control stuff, everything. Okay, so Snowflake, you have micro partitioning. So micro partitioning is the important one. So your Snowflake, like the entire system, it's like micro partitioning is the one which helps you to improve the performance. Okay, so today we focused about the architecture. We discussed about the architecture, and I showed here. I loaded the data. I created a table and loaded the data. Let me do few more things. I am going to create a user. So we have raw data here. We have the raw data, the sales record. This is the raw data. I am going to create a table. I'm going to create a view. I'm going to create table and view. So I'm going to create a view. On the top of the sales raw data, I'm creating a view. I'm creating a monthly summary. I'm creating an aggregated table here on top of the raw data. Okay, so I'm creating a multiple tables. So I can go to Snowflake, go to catalog, schema. So we created multiple tables here. I created a view. You can see I can see a view. Okay, I can see a stage. I created a stage, AWS stage. I created a file format. So all this thing are called Snowflake objects. Snowflake objects. So we have database. We have schema. Within schema, you have tables, views, stages, file format. So we have multiple objects. So I have monthly summary here. So I have monthly summary data, aggregated data here. I have raw data here. So I have the raw data and I create a view. And I have the AWS stage. I have the staging link here. I can see the link here. Okay, so now I can provide access for my users. I can create users. I can create users here. Okay, I can create new users and give them access. So let me create new users. So I'm doing everything as a SQL. Why I'm doing everything as SQL? I'm not doing from UI because in real world, you have multiple environments. So I have in organizations, we have multiple environments. We have dev, QA, stage, production. Okay, so if I'm going to work on all this environment, I cannot do it from UI. If I do it from UI, each environment I may commit manual errors while creating the objects, while creating tables, while creating the views. I may commit errors. So I am going to create this SQL. I'm going to create all the objects, create the Snowflake objects using SQL. Okay, using SQL, so that I can take the same SQL and deploy it here in QA, deploy it in stage, deploy it in production. So you will commit it to GitHub. So you will have a version control. You will have a GitHub or any version control where you will commit this Snowflake SQL files, and that will be reviewed. Okay, there will be a reviewer who will review your code, review your SQL, and they are going to get approval for this business approval for deploying it on higher environment. Okay, so the higher environments, these are the higher environments. So this is our development. So we are developing it on dev environment and deploying it on higher environment. So I'm talking about a bigger organization where they are having multiple environments. If you're working for a very small organization, they are having only one environment. You don't have to do all this thing. So you may work on a single system, but in a larger enterprise, they have multiple environments. So this is a standard practice where we do it. Okay, so that is why we are writing everything as a SQL. We are creating table. We are creating everything as a SQL here. So I can deploy it on multiple environments. So we will create a user.
Yeah, can you go back to that picture where GitHub?
Yeah.
So just to clarify, here we are developing and then pushing it to the GitHub, right, for the approval, and after that it will be deployed in the QA stage and production, right?
Correct. Yeah.
Okay.
So it is like each has their own approval, right? We call it as MR, or we have release process. We have a release process. So that means deploying in QA, you will create a one branch. You will create one branch for QA. Okay, that you will deploy it in QA and you will get an approval on QA. Then you will deploy it in stage. Then you will deploy it. It's not that I developed everything straight away. Take the same one and deploy it in all the environment, right? So you go stage by stage. You deploy it in QA. You get this QA approval, then stage approval, then production approval. So that's how it goes. Here integration testing happens. Here user testing happens, and then it goes like.
Okay.
Okay, we will discuss about it. I'll explain this in detail. When you are going to work on the projects, we will use GitHub. So in the GitHub, I'll show you how projects are integrated and how like quality of code is maintained, how review process happens, how PR get approved. I'll explain about everything. We will discuss about that later. So for now, I'm telling it high level. So why we are writing SQL, why we are creating objects instead of creating from UI, why we are creating in SQL, that is what I'm explaining. So because if I do it from UI, in all this environment, I can commit errors. I cannot create it all this thing. So if I create this SQL, it's easier to automate. I can create an infrastructure as a code. I can automate all this thing easy. That is why we are writing as a code. We are creating all the object as a code. Okay, let me create the users. I'm going to create 2 users. I'm going to create a role.
Roles and users creation is part of our role. It is admin.
It's admin account. You don't do it.
Admin.
It's part of it. I'm just showing it for the demo purpose. It's normally not done by developer.
And with the help of these roles and the users can access this data warehouse,
Yeah,
right?
yeah, that is what I'm going to show now. Okay,
Okay.
I'm going to create 2 users, sales user, marketing user, and I'm going to create role and give access to them. I'm going to give access only to the monthly table and view here. I'm not going to give to the raw table for the users. I ran all these queries. You can see I created a role I granted access to the roles. I created users. I created a workspace. I'll explain this later. We will see all this thing later. I'll explain about all this thing later. So for now, I created a user. I created a role, and I've assigned the role for the users. You can see the final step. I'm assigning the role to the users. So we have two users here. We have two users, sales user. I will take the URL. I'll use another browser. I will log in as a user. Okay, I'll log in as a user. Let us see. I'm going to log in to the Snowflake as the user, sales user.
The roles will be created on the based on the databases or the tables or any specific groups.
The roles will be created. Why we are using roles, right? Why we are not directly giving access to the users? We have in Snowflake, we have role-based access management. Okay, so it's easier to give access based on role because today you are working on an organization. Tomorrow you are leaving the organization, another user is joined, another developer is joined. If I create a role and give permission to the role, I can assign that role to any user later point of time. Okay, if it is directly attached to the user, it's difficult for me to maintain for a longer duration. That is why we create a role, we give permission to the role, and we attach the role to the users. We don't give permission direct to the users.
No. I mean, the roles will be creating on basic, specifically on the database, or the on what basis the roles will be created.
So the roles, there will be multiple roles will be created. It's based on the usage, right? So you are a data engineer, you need limited access, or you're an analyst, you need business access, you need access to the business tables, you need goal table. Like based on the usage, you will be given access, and it is not done in a normal way, right? It goes through approval process. We have approval process. There is an admin there who maintains this, who get business justification and gives permission for you. In the production, I'm talking about. In production,
Mm.
if you want access to the tables, it goes through admin, and admins provides you access. They assign you roles. They will provide you different kind of roles. Like if you want admin privilege, you need to get a business approval, then you assign your roles. Okay, so let me complete this. I'm creating a sales user. And I'll log in as a sales user. So you can see here, I logged in as a sales user. I can still see admin, but if I go to admin, I can see nothing here. If I go to accounts, I don't see anything here. If I go to compute, I see only one warehouse, retail warehouse. I don't see other warehouse. Okay, this retail warehouse is created and assigned to me. Okay, so for the sales user, without warehouse, he cannot run. So we have created a retail warehouse and assigned it to this user. And if I go to catalog, I can see demo database. I can see tables here. I can see only monthly table. I can see only views here. Okay. So here I gave access to this user. So the permission here, I gave the permission. I am the admin. I am controlling the access for this user. So I gave permission, only limited permission. I gave read only permission for this user. So you can see the summary, monthly summary. You can see the view. He cannot see the raw table. Okay, he cannot see the stages. He cannot see the other formats. He cannot see the other objects here. He cannot see the other objects. He can see only few views. Okay, so this is how RBAC. We will see about RBAC. So we are in Snowflake. We use role-based access management. So here I created a users, and that user I gave access to the table. So you can see the thing here. I'll show it here. You can see here. So you can see here, this line tells you select on table monthly summary. Okay, select on view. Okay, so I'm giving read-only access. You can see here I'm giving read-only access to this users. Say for the role, I'm giving access. I'm giving read-only access here. I'm not giving write access. So this all is controllable. You can control, you can control everything as admin, as a Snowflake admin. You can create users and you can, so you can see now, if I go to users, I can see new users. I can see new roles. I can see new roles. I created the sales role. Okay, and then I gave privilege here, what tables they can view. So I can control it. I can do it from UI. All this thing, whatever I did from SQL, I can do it from UI. I can do it from SQ. Both you can do it. Okay, so far we did some basic stuff. So we did some basic stuff so far. So we started with creating a table and getting the raw data from the stage, loading the data into table. So let me go to the, so this is the full script. You can see the full script. I'll be attaching this full script where you can see this has end to end. So I can take the script, run it on any. So this will work on any environment. Okay, so I'm converting into SQL script. So I can create all these objects by running the scripts. Okay, so the script, what we did, we created database, we created stage, we created a raw table. I created a raw table. I also loaded data from S3. Then I created a view. Okay, I created a view. I created a monthly table, monthly summary table, the aggregated table. Then I created a user and gave permission for the user to view the data. Okay, that is what we did. Okay, so we will stop it here. So far, we have started on the architecture side and we went into a basic scenario and we have covered about the architecture, the importance of Snowflake, understanding the architecture. So we understood about how the data is stored permanently and what is micro-partitioning we have seen, how micro-partitioning works. And so far we used warehouse. I used existing warehouse. So in the warehouse, compute layer, I used this warehouse. Okay, I did not go for a bigger warehouse. I used small warehouse. I can create a large warehouse, but I used a small warehouse. So in the next class, we will discuss about warehouse, how we can create a large warehouse. So what are the different type of warehouses are there? How you can run concurrent queries? We'll discuss about detailing about warehouse in the next class. So today we started on the architecture. We focused more on the storage layer, storage data permanently, and micro partitioning and different layers, services layer, what it does, compute layer, what it does. Okay, so any questions from anyone? So let me go through the questions. I see a lot of questions on the chat. So I see a question. If you create stage using command line in Snowflake, where it is created without credentials. So if you create an internal stage, so you can create internal stage. So if you create internal stage using command line, it will not be visible in UI. Okay, so internal stage has three type. So you have user stage, you have table stage, you have named stage. Okay, so you have three type of stage. So we will discuss about the internal stage, external stage detailing. So I'll explain that when we are starting on the stage, internal stage. I'll show that how it can be done. So we have so far done creating stage. So you can see here, Snowflake managed. So internal stages here, you can create internal stage. Okay, so you can create internal stage. You can create external stage. So whatever we are using are external stage. S3, Azure, GCP are external stage. We are using external stage. Internal stage you can create it. Okay, so I will show that how we can do it from command line. You can create it, but it is for development purpose. Internal stages are used only for development purpose. If you are going to work on enterprise, if you are going to work on real world, we create external stage. Okay, that is why we started with external stage. We did not go for internal stage. I'll show later about internal stage. I'll show you how to do it internal stage. All queries are processed in account one, account two is only. Okay, I've answered that already. We're using credentials, do we use protocol which are used in backbone? Okay, so I see a question on the stage creation. So when creating stages, okay, you can see the stage details here. So you can see here, it says access detail credentials, yes. Okay, and it's location AWS. It's your AWS, your Snowflake is running on AWS. Your Snowflake is running on AWS, and your account is on the cloud. Both are there in cloud, so it can recognize the credentials. So if you provide the secret keys, it can understand the secrets and it can talk to AWS. Okay, so that is how your stages are created. Okay, so if I create my credentials correctly, okay, so if you can see here,
Well, I get that. I get that. But the ask is, I mean, it is a bit broader perspective. You understand? See, the Snowflake managed AWS account may be in some other region, let's say US region, but the AWS account which I am managing, my AWS account, may be in some other region. Now, between these two regions, there is something called as a firewall or a gateway.
no,
Then
you are
how do
using
we?
so region. IM is not region specific. Okay, the IM is not region specific. The users which we created are across all the region. Okay, so that is why even
Hmm.
though your AWS is different region, your Snowflake is running in different region, but it can recognize the user account because IAM is not specific to region. IAM is globally available. Okay, so IAM is globally available. The users what we created, the secret credentials what we created are globally across all the regions. So it can access your account and then it can access your you can access your IAM details and it will check if your IAM has S3 access. So if this user account has S3 access, if it does not have access to S3 bucket, it's going to throw error. If it has access to S3 bucket, then it is going to pull you the data. So that is how it works. So they are using this IAM details. IAM is globally available, and this user has access to the bucket. So that is how it's able to pull it.
So probably in the next lecture or demo, can you show, even though you have valid key ID and key secret, there is a rule which prevents access to the S3 bucket. Can you show it in next demo? In which situation would the access get prevented even though the key ID and key secret are valid?
So you are saying that even though the secrets are valid,
Yeah,
my
yeah,
bucket is not accessible.
yeah. Can you show it in the next demo? I want to see.
Oh, what you are saying is like I don't get it. So what you are saying, you have a bucket and that
Hmm.
bucket is blocked. That is what you're saying.
So let us say the URL you mentioned to S3 bucket is correct, but there is some
Okay.
admin who changed the way the bucket
Yeah,
is
like
supposed to be accessed.
so I can
So
restrict
the
the
access
permission, right?
policies,
So for
access policies
example,
are got changed.
so I go to my user. So this is my user account. I can remove the permission. Okay, I
No,
can remove the
so let us
permission.
say only certain IP addresses are allowed to access the content of this S3 bucket. Now,
I removed
even though
permission
the
for this user. Now this
no, no,
user
no,
cannot access it, right?
no, no, not about the permissions. So only selected IP addresses are allowed to access the content of this S3 bucket. So how
Yeah.
does
So you are asking some specific scenario which we will discuss later. You can I'll note this question. I'll tell you this later, but I will not show
Yeah,
it in next session. I'll cover this later.
sure. Probably I'm interested in that, Will, to understand how that works or how does that prevent or please
No, I'll talk to
show
you
that
separately.
best.
You can message me separately. I'll talk to you. This is some specific scenario, right? So this is
Yeah.
a specific scenario for a specific use case. So why I should
Okay.
cover this next, right? So we have a plan. So we are going by the plan. Okay. So we have a
Okay.
set of plans to be done. So we are going by the plan. So whatever the questions you have, you can send me the question. I'll answer it separately. I'll explain that separately too.
Sure. Sure.
Okay. Okay, because I don't want to confuse everyone, right? So if I'm going to tell this thing and confuse others, right? Why for one person I should be a confuser? This is a rare scenario which not everyone is going to face in real world. Okay, this is a rare scenario. So that is why we'll take it separately. You can message me the thing, scenario of what you have, and I'll try to answer it separately for you, and we'll not handle it in the
Yeah. Yeah.
class.
Yeah. Yeah. It's
Okay.
fine. It's fine. It's fine.
Okay, fine. Okay, so any questions from anyone? So I see a question on,
This is Rashid.
yeah, go
So,
ahead.
accessing the S3 bucket, this is the way we can access the S3 bucket. Staging is the way we are, no, the source you have shared this way. This is the way you can access the S3 bucket. Am I
So
correct?
here we are just reading the data, right? I'm not putting the data into it. I can access this bucket. I can load it and unload data into this S3 bucket. Okay, so that means in the real world, this is going to be a source for you. So where other teams are going to put the data, you are going to take the data and do ingestion into your data warehouse system. Okay, you are going to do ingestion. So sometimes I may have to give the data back again. So that means we have to do, after doing something, I have to unload it and I have to give to other teams into S3. Okay, so in real world, you may do loading or unloading, and we may have multiple accounts. So we may use multiple AWS account. I'll create multiple stage and I will load and unload it to multiple environments.
Okay, thank you. And one more question.
Yeah.
Okay, the SQL you have executed right now. So I have to create like one account in AWS and another account in Snowflake. Am I correct?
Can you repeat it? What is it?
So the SQL you have
Yeah,
created the table and then created the stage and then copy the table into
correct.
Snowflake. So if I want to execute these queries, so I have
Hmm.
to create two accounts. One account in AWS and other account in Snowflakes. Is my understanding?
Yeah, so here I'm using stage. Okay, if I'm not going to use the stage,
Yes.
then you don't need AWS account itself. So here I have my data. My data is sitting in AWS. So I created a stage. So that is why we are creating AWS account. So here, if I'm not using stage, so if I'm going to create an internal stage here, in the next session I'll show it. I'll show an internal stage here. Instead of AWS, I can create an internal stage and put my CSV files into the internal stage. Instead of using external stage, I can create an internal stage and place my CSV in the stage here. So I don't need AWS itself. I can use my internal stage and have the CSV file, JSON, everything placed here in the internal stage, and you can use it from stage. So I don't need AWS account itself. I can use only this AWS Snowflake account is enough for me to use it. And Snowflake internally uses a cloud account. They are using a AWS or Azure account. That is the account provided by Snowflake. They are using it, but I don't need a separate account. I can use the internal stage for holding the data. Okay, so
Okay.
you can create an internal stage instead of creating AWS stage, and you can use it that for running this demo. Or let me show it quickly. So I can create. So I'm now creating internal stage. If I go to database, I can go for catalog, stages. Okay, here I can upload the file. I can take the CSV file from my local. So I can upload the CSV file, and then instead of using AWS stage, I can use this internal stage. Okay, I can do copy command using my internal stage. Okay, this is how you can do it. So you can don't have need a AWS account. You can use the internal stage, and then you can upload the file. So as I did, I can upload the file from UI and can do it from UI itself.
But for the big data, we need to use the external one, right?
So for demo purpose, for development purpose, you can create internal stage. Okay, for real world, we always use cloud, AWS or Azure data lake account. But for development purpose, if you don't have cloud account, I don't have AWS account, still I wanted to learn Snowflake, then you can do this, create an internal stage and work on internal stage. And if you are going for interviews, they will ask both. They will ask about internal stage. They will ask about external stage. They want you to have good knowledge about working on the external stage because that is where you are going to use in real world. So and in real world, we are not going to use hard coding the credentials, right? We are not going to use this. We will use a technique called storage integration, which we will see it later. I will show storage integration where I will create a role in IAM. So I will create a role in AWS. I will use a role and I will control the access. I will not hard code the details. That we will see it later. We will see about storage integration later. For now, starting with credentials, later we will get into storage integration. Okay, any questions from anyone? Any questions on? So I'm going to send you the script today. So you can try to use the script. I'll also add the internal stage here. You can use external stage or you can use internal stage and try to run the command. Okay, and then if you have any issues, you can reach out to me in WhatsApp. Okay, so we will stop it today. We will connect again on next Monday. So next week, we will have sessions on Monday, Tuesday, Thursday and Friday. We will have 4-day sessions. So this week we did not have sessions on Monday, Tuesday, and Thursday, but next week we will continue to have sessions on 4 days. Okay, so we will stop it today. We'll connect again on Monday. I'll share the video files. I'll share the SQL files. You can try it out. If you have any questions, you can reach out to me in WhatsApp. Thanks everyone. We'll connect again next week.
Thank you.